Sugar and spice and all things nice, that's what little girls are made of. Slugs and snails and puppy dogs' tails, that's what little boys are made of. Well, actually, not quite. What makes men men and women women? Well, women have the X chromosome and men have the Y chromosome in their DNA makeup. But what does that mean? Well, I'm joined for our weekly science slot by Luke O'Neill, Professor of Biochemistry and Director of the Trinity Biomedical Sciences Institute at that college. Two X's or an X and a Y?
That's right, Pat. It's all down to if you have a Y chromosome or not. It's not if you're wearing David Beckham underwear. That doesn't make you a man. It's if you have this special chromosome called the Y chromosome, that makes you and me men. And women have, as you say, an X chromosome.
Now, I've been reading some of the stuff that you sent me, and it turns out the Y chromosome, the one that makes us men, is actually shrinking.
It is. It's a stubby little thing. It's the shortest chromosome that we have is the first problem. And that's made it difficult to work on. And people have trouble isolating it and studying it. The second thing is, as you know, DNA makes proteins and it's this genetic code. The Y chromosome is full of repeats. So it's like men, they repeat themselves a lot. It's just indicative of that. But it's very hard to work on. And lately then we've got our teeth into it basically and we now know a lot more about it.
Now, the maleness. It turns out that, say, the generation of testes and so on, that's down to just to one chromosome.
Yeah.
So what are all the other lads doing?
Well, it's interesting. About 30 years ago, there's a single gene, Pat, on the Y chromosome called S or Y, which is sex-determining region Y gene. That's sufficient to make a male. And even if you put that gene into the X chromosome artificially, that mouse will become a male. You know, so it's a single gene determines testes development and testosterone. So it's quite simple at one level that you're a male because of one gene that happens to be on the Y chromosome. Yeah,
one gene will do it. Will make you have the appearance of a male.
That's right.
So what are all the other genes in the Y chromosome doing?
Yeah, well, again, they thought it was just that one. And of course, that particular gene controls many other genes and other chromosomes and makes testosterone work properly and what have you. But then last week, literally, very recently, they found there's 18 other genes now on the Y chromosome that seem to have a role as well. And these ones don't make you a male, but they make you a viable male. So the S or Y gene makes you a male, but the other 18 make you a healthy male, they reckon now. So it turns out we're now reconfiguring our view of the Y chromosome entirely. It's not just one gene after all, it's got 18 other genes that are needed somehow.
Now when you say viable, what does that mean in terms of maleness? I mean, in the past it might have been you were a good spear thrower, so you could slay an elk at 50 metres. Yeah,
this actually just means getting born in the first place, I think, because the S or Y alone, a certain number of mice get born with that and they become male. Many aren't that viable, they don't live very long once they're born. If you have the other 18 though, then you get a viable male, I guess, baby growing up, a baby mouse grows up fine, so the viability is all about surviving, I guess.
And what about the women then? If you've a female child who's got the double X rather than the X and the Y, are they kind of much more likely to be viable?
Well, they may be,
because they're girls.
They may be, and in fact on the X chromosome there are 2,000 genes, you see, and whereas the Y only has about 19 or 20 that we know about. So they seem to have a lot more genes in them, if you like. And of course females have two X's. They get a double dose, and that gives rise to, again, certain traits in the female that may give it an advantage over the male.
Now, the Y chromosome also, it seems, gives us information as to whom our forefathers might be.
Yeah, exactly.
How does that work?
So we inherit the Y from the father, obviously, clearly, because it's male, and you can track back your ancestry then by looking at the Y chromosome and comparing different Ys between people. So we know, very interestingly, 1 in 200 men on Earth are descended from Genghis Khan. Isn't that incredible? So Genghis Khan, very active, obviously. He had all these children, and it looks like 1 in 200 humans are descended from Genghis Khan. Because, in other words, that your Y chromosome is like his, which tells you you're related to him because you inherited it from him.
So was he having his way with the wives or the partners of all his generals and
he was
subordinates?
And they reckon he may have had 10,000 children, Genghis Khan, to explain this, right?
They have to, when they work it back, if 1 in 200 of the male population on Earth is descended from him, he had to have, at that time, 10,000
at least 10,000 children. And what they did in those times was, Pat, is interesting. They made sure they had sex with all the women, but they killed the male-borns of their enemies. So they were actually weeding out the other male children. And
this
then
is
their
King
own
Herod, basically.
This is a bit like King Herod, there's evidence. It's called hegemony is the name they use for this, where one dominant male has thousands of children and kills the children of his rival. Let's say his prime minister's child or whatever. He's the king. So he gets rid of that child and kills that child. So isn't it strange?
So the only males that are going to be knocking around and in their quest for power will be his own offspring.
Exactly, yes.
But they'll have loads of girls to pick from.
Well, they will indeed, absolutely, yeah. But basically his Y chromosome then dominates the population is the way to think of it.
If you have a sex change, given that the Y chromosome is what makes you male. How does that work? I mean, do you change a chromosome?
Well, no, it's all about testosterone again, if I remember. So what this SRY gene does is it controls testosterone. That's the hormone that gives you all the male traits, facial hair, testicle development, all those things that we know that are male is driven by testosterone. So if you give a woman testosterone, she will become more masculine. And clearly her tissues won't change too much if she's an adult. But if she's a baby and testosterone goes up in that child, she will begin to develop secondary features of the male. So you can actually have a sex change then hormonally is what happens in that case.
Now, susceptibility to disease. There are some diseases which men get more than women.
Yeah.
Does the Y chromosome tell us about that?
Well, what's fascinating is these 18 genes now, because remember, up to this study, which only came out a couple of weeks ago, the Y chromosome had this one gene, the SRY. There's 18 more now that we need to look at. And the question is, what do those genes do? Will they explain some of these diseases? And the best example that we have is Parkinson's. It's much more common in men, Parkinson's, than women, for instance. And there's a range of other diseases similarly that are more common. So the question is, will the answer to Parkinson's possibly lie in those 18 genes? And there could be a defective gene there in some way. So again, a big interest in trying to figure that out.
And is it possible using gene therapies after the child is born, isolating the fact that they may someday get Parkinson's, give them a gene therapy that will eliminate that possibility?
Exactly. So the genetic basis could be uncovered partly through studying these 18 genes. The second one is baldness, Pat, of course, which is the male trait. And that was thought to be testosterone levels falling, sadly, and you begin to go a bit bald. That's not the case. And as you may know, the balder the man is, often the more virile, so he is the view anyway, he has slightly more testosterone. So it's not clear why hair loss happens. And again, is that something to do with these 18 genes? And you may have a different version to me, and therefore you're going to go bald and I'm not. So the answer to baldness between males may lie in specific genes among these 18 on the Y chromosome.
Now, when people have defects in their chromosomes, some of these can be quite catastrophic, isn't that so?
They can indeed. And of course, there's various syndromes where you carry an extra chromosome. So there's a thing called Klinefelter's syndrome where you have two X's and a Y. Now normally you have one X and one Y if you're a male. That extra X chromosome with the X and Y begins to create all kinds of health problems. There's about 20 different diseases actually where these X and Y chromosomes go a bit wonky, if you like, and some are deleted, some are duplicated. And that's interesting medically as well to understand those.